Okay, today we're going to do section 12.7 two-way tables. Before we get started, we do have a couple of vocabulary words. The first one here is what a two-way table is, and it displays two categories of data collected from the same source. What that means is every person being surveyed is going to be asked two questions, and the results of both of those questions will be put in the same exact table. The joint frequencies are the entries that are in there. I'll explain that when I show you the first example. And marginal frequencies, this is the one that you have to calculate. These are the sums of the rows and columns in the two-way table. These are going to be the totals. All right, so question number 1. Says you randomly survey students in your school about their grades on the latest test and whether or not they studied for the test. The results are in the two-way table. So again, they were asked two questions. They were asked about their grades. Did they pass or fail? Then they were asked about their study habits. Did they study or did they not study? These numbers in the table, these are the joint frequencies. It's telling us that 21 students both studied and passed, 2 students did not study and passed, 1 student studied and failed, and 6 students did not study and failed. Okay, so what we're being asked to do down here is to find and interpret the marginal frequencies for the survey. Again, marginal frequencies are the totals. So basically what we're going to find here is what is the total number of students that passed the test. 21 plus 2 is 23 students. Total number of students that failed the test will be 7. Total number of students that studied will be 22. And the total number that did not study will be 8. There is a last one. The last one is the total amount of students that were surveyed in all. And how you get that is you add these two numbers together. So 23 plus 7 is 30. And it should match these two numbers here. So 22 plus 8 is 30. And that is the total number of people that were surveyed. All right, so the second part is to interpret. Interpret, as we've been learning all year, is explaining what that means in real life. Basically what you're going to do is you're going to take these 5 numbers here and you're going to provide them with some context or some labels that make them have some sort of a meaning. So the 23 was the first one. So 23 students passed. That's the total number of students that passed the test. 7 students failed. That is the total number of students that failed the test. 22 students studied. 8 students did not study. And again, the last one, this is the one that's most forgotten, is this 30. 30 total students were surveyed. Next one. You randomly survey students in the cafeteria about their plans for a football game and the school dance. The two-way table shows the results. Again, we have 2 questions here. It's, did you attend the football game or not? Did you attend the dance or not? And these numbers are the joint frequencies. These are the responses. Find and interpret the marginal frequencies for the surveys. I'd like you guys to pause the video and go ahead and find those total numbers, the 5 of them, and then interpret them for me. All right, this is what you should have come up with. 40 attended the dance, 36 did not attend the dance, 51 attended the football game, and 25 did not attend the football game. And when you added up those numbers, you both got 76. That are the total number of students that were surveyed. This one represents a t-shirt order. This is one I see more used in real life, where you're collecting an order for something and everybody's buying different stuff and you kind of organize it in this table. And what a two-way table is very helpful for is making sure that you got the chart right, and that at the very end of the day your totals all match and all line up. I'd like you to go ahead and pause the video and go ahead and find the marginal frequencies for the t-shirt order. Okay, let's see how you did. So we get 29 was the total for all of the different color combinations. 25 smalls, 30 mediums, 35 large, 30 extra large, and 25 double X for a total of 145 ordered t-shirts. All right, last one we're going to do. You randomly survey students between the ages of 12 and 17 about whether they ride the bus to school. The results are shown in the tally sheets below. And when you're collecting data, you're not going to collect it at a nice, neat table. There's got to do it in some sort of way, and in this way they did it with tally sheets. So the first thing I would do is I would find the totals of each of the tallies. So here for the riding the bus for ages 12 to 13, this is going to be 24. For 14 to 15, this is going to be 12. And for 16 to 17, this is going to be 14. For 12 to 13, this is going to be 16, not riding the bus. For 14 to 15, this is going to be 13, not riding the bus. And for 16 to 17, this is going to be 21. The directions say, make a two-way table to represent the data. That includes the marginal frequencies. Again, when you're going to make your two-way table, the first thing you have to figure out are what are the two questions that were asked. So the first response was, how old are you? So I'm going to write age here at the top. And the different responses were 12 to 13 years old. So 12 to 13. And then the next one was 14 to 15. And then 16 to 17. Second question was, do they ride the bus? So I'm going to write riding the bus. And the two different responses were either yes or no. And if we kind of draw our lines to separate our different answer choices here, that will create our two-way table. And then we can fill in the numbers that we found earlier. So our yeses were 24, 12, and 14. Our no's were 16, 13, and 21. And then we had to include the marginal frequencies in here, so we're going to have to do our totals. When I add up this row, I'm going to get 50. When I add up this row, I'm going to get 50. This column here is going to give me 40. This one here is 25. And this one here is 35. I'll add them up. That's going to give me 100. I add them down. That's going to give me 100. And that would be our total number of people that were surveyed, or 100 people. Next part of the test says, for each age group, what % of the students in the survey ride the bus to school or do not ride the bus to school, organize your results in a two-way table. So we're going to create another two-way table that has the same exact categories as the one before. So again, the first question was, how old are you? So that's the age. 12 to 13, 14 to 15, 16 to 17. And then we were asked about riding the bus. And those were yeses or no. Again, we'll draw our lines here. And that will create the table. Now, for specific with the percentages are not going to be out of this 100 because they want it specific for the age groups. So each age group will have a total combination of 100%. So if I'm doing the 12 and 13, I want to do a percent for 24 out of 40. And 24 out of 40 is 60%. For the no's, it was 16, so 16 out of 40, that's 40%. And I know that I got that right because when you add them up, you're going to get 100. For the 14 to 15 age group, we have 12 out of the 25. 12 out of 25 is 48%. And then 13 out of 25, that would be 52%. And again, this age group, 100% is the total. We're not going to put the marginal frequencies in here because for percentages, it doesn't make any sense to do that. For 16 to 17, 14 out of 35 is 40%. And 21 out of 35 is 60%. So the last part of the question says, does the table show a relationship between age and whether the students ride the bus to school? And as we kind of look at our table here, it looks like the yeses are going down in percentages as the students get older, and the no's are going up. So there seems to be a trend here. So the answer to this question is yes. And then when we explain, we have to kind of say why does that make sense? Why does it make sense that it's a yes? Well, hopefully you know this, but once students start to get older, they get their driver's license. So when they get their driver's license, they're no longer going to take the bus to school. And if you want to say, well, why does 14 and 15-year-olds, why do they have a higher percentage even though they don't have their driver's license? Well, it's because they probably have friends or older siblings that ride the bus to, or that drive to school. So that would explain why these percentages are going up for the no's and down for the yeses. So I would say yes because older students either drive or have friends who drive. And that would explain the results of that table. All right, that's it for today. Go ahead and work on the assignment, and we'll touch base again tomorrow. Have a good day, everybody.